Okay, now for section 1B, for section 1B, we're going to be looking at what we call propositions and truth values. Very, very important, especially the truth values. But propositions are very important for us to be able to do a truth value. First of all, what's a proposition? I already used the word. What's a proposition? So a proposition is what we're going to call a claim, right? I'm going to say something. I'm going to claim something. And my claim, my proposition, is a statement that can either be true or false. So again, a proposition is going to be a statement, it's going to be a claim, but it can be true or it could be false. Now, the structure, my proposition should look like a complete sentence. Again, it's a complete sentence. I am claiming something, and then my claim is either true or false. Let's take a look at an example. You might be like, well, can you give me an example? Okay. All students, let me write this thing down. All students in this class are females. Again, right now I'm not looking whether my statement is true or it's false, but it's a statement. I'm claiming something that could be true or false. That is what we call a proposition. All students in this class are females. Now, pretty sure, if we look around and we look at our students in our class, we can see this claim is actually false. Now, in here, I'm not going to start looking at claim. I'm not going to write the whole claim. I'm going to abbreviate it. And now for proposition or for a claim, I'm going to use the letter P. So sometimes I might say claim P. It's not that I want to abbreviate this sentence only. It's just that I'm saying I'm having a claim. Remember, a proposition, it's a claim. I'm stating something that can either be true or false. That's what a proposition is. Later on, we're going to be looking at the values of propositions. We're going to be working with propositions, but I don't want you to focus too much on the wording of each proposition. Instead, I want to say there's a proposition P. There's a proposition Q. There's a proposition R. I'm not going to say the exact wording per proposition because I don't want us to focus on the wording. It's just that at this point, I want you guys to know what a proposition is, but later on, I'm just going to call it P or Q or R or any other letter that I choose. But again, at this point, slide number 2, I just want us to know what's a proposition. And I want you to know that I can use it as a P, I can call it letter Q, I can just call it, I can refer to it as any letter that I wish. Now, any proposition has two possible truth values. It could be true or it could be false. So every proposition that I make, the proposition that I just made on my previous slide happens to be false. But any proposition can have two values, a true value or a false value. Now, a negation of a proposition is another proposition. So a negation is another proposition that makes the opposite claim of the previous proposition. As an example, remember how I had all students, let me just have that again. All students in this class are females. Remember, that was my initial proposition. Now, a negation will make the opposite claim of this. Now, we have to be careful on what's the problem. Some people might say, oh, wait a minute. If they're not all females, what if I change that to males? Let me change this to opposite of female, it's male. So now my new claim is all students in this class are males. Unfortunately, that claim happens to be false as well. So the word females, it is not our problem. Word females is not the problem. The problem in this case is the word all. The word all is basically our problem. So the negation, I'm just going to change this to, instead of the word all, I'm going to say not all. Not all students in this class are females. Remember the initial claim, all the students in this class are females, it was a false claim. Now, when I negated, not all students in this class are females, it changed from false to true. So a negation of a proposition is another proposition that makes the opposite claim of P. We usually just call it not all. So if I came and I said, initially I said, instead of all this wording, I call this proposition P. Well, the negation, right? The opposite of P, I'm going to say the negation will be not P, right? All students in this class are females. So the negation of that is not all students in this class are females. But in mathematics, we like to use symbols, and the symbol for not is going to be a wiggly thing like this, not P. You guys are going to see that sometimes. Now that we know what a proposition is, now we know the negation, let's take a look at our truth tables. A truth table is a table with a row of each possible set of truth values for the propositions being considered. Again, at this point, I don't want you guys to focus on the wording per proposition. So I'm going to say there is a proposition called P. Right? I'm making a claim. I'm not going to go over the wording of which claim am I making. I'm just saying I have a proposition. I'm going to call it proposition P. My proposition P could be true or false. Now, my proposition not P, we said it was the opposite of P, so it could be false or true. Each proposition, as you notice, has two possible values, true value or false value. But P, the value of P is opposite from the not P. Since we mentioned opposites, find the negation of the proposition Amanda is the fastest runner on the team. Okay, so I'm going to find the negation. So I'm just going to say it, Amanda is not the fastest runner on the team. I just negated. So I just went from is the fastest to is not the fastest. Now, if the negation is false, is Amanda really the fastest runner on the team? So the new statement that I just wrote, Amanda is not the fastest runner on the team. So this negation happens to be false. So that means not is not there because it happens to be false. Is she really the fastest runner? Well, once I negate the not, Amanda is the fastest runner on the team. So in this case, I'm going to say yes. Yes, it is. Now, there's two things that we call double negation. Notice how in the previous one, when I had the Amanda was not the fastest runner, and then I negated that, so I just took it out. Sometimes we can just erase it. Sometimes we can just call it not. So that's what we call the double negation. Not P has the same true value as the original proposition P. Let's take a look. Let me see what this statement really says. Let me see. Let me read it again. The noble negation, not P, has the same true value as the original proposition P. Okay, so here I have my truth table, and I said P could be either true or false. My not P Remember, it's going to be the opposite of P. So if P was true, not P is false. If P was false, then not P is true. Remember, the one not P is the opposite of P. Now, let me consider this phrase, not P. And then I have it here. Not P is going to be the opposite of not P. So not P is the opposite of not P. So if not P is false, then not P is true. If not P is true, then not P is false. Now our statement to begin with, the noble negation said that not P, so all of these values of not P has the same true value, so it's the same order as the original proposition P. And we can see the order happens to be the same. That's what the double negation means. Not P is the same thing as just P. Two nots cancel each other out. Now, after reviewing data, let's take a look at an example here. After reviewing data showing an association between low-level radiation and cancer among older workers at the Oak Ridge National Lab, a health scientist was asked about the possibility of a similar association among younger workers at another lab. And then this scientist, he was quoted as saying, "My opinion is that it is unlikely that there is no association." What? My opinion is that it is unlikely that there is no association. Does the scientist think there is an association between the low-level radiation and cancer or not? But let me focus on a couple words. Unlikely. Unlikely means not likely, right? It is unlikely that there is no association. So there's two nots. But remember how not P was the same thing as P, and I said that two knots cancel each other. So in this case, this not and this no cancel each other out. So in reality, what this scientist is saying, once I cancel that out, let me rewrite this. What the scientist really said was, my opinion is that it is likely that there is association. We have to learn to read between the lines. Well, in this case, we have to be able to tell that there's a double negation and they cancel each other out. So in reality, what the scientist said, my opinion is that it is likely that there is association. So now the question was, does the scientist think there is an association between low-level radiation and cancer? Yes. Yes, the scientist does. Now we do have some things that we call connectors. In logic, we have things that connect, and they're going to be words such as and, or, and the phrase if, then. Right? These are the connectors. These are going to connect they're going to connect propositions in this case. So propositions are often joined together with logical connectors, words such as and, or, and if, then. Let me take a look at each of them. Let me take a look at the word and. Now, the word and, we call it a conjunction because it puts things together. Given two propositions, let me call them P and Q. Given two propositions, the statement P and Q, but keep in phrase, I'm using the word and. The phrase P and Q, this phrase, this statement is called their conjunction. It is true only if P and Q are both true. Interesting. It is true only if P and Q are both true. So let's actually work on the truth table. Now, notice that even though P, I have two possible choices for P, I happen to have 4 rows in this truth table. You might be wondering, why is that? Because P has 2 possible choices. Q is another statement. It's a whole different statement that also has 2 possible choices. And 2 times 2 happens to be 4. So I'm going to have 4 different rows. So looking at my statement P, again, I don't want us to focus too much on the wording of a statement, but let's say I have a statement. It could be true or false, but because there's 4 rows, the half of the row, the first half is going to be all true, because my statement P could be true, or it could be false. Let me have the lower half to be false. So notice I change every 2. Now for Q, I'm going to change every 1. So I'm going to go true, false, true, false. And then I was told earlier, that P and Q, it is true only if P and Q are both true. So one of them is true, but not the other, it's false. So it is true only if P and Q are both true. So as soon as I see A false, then it's false. So if P and Q are both true, I'm going to say P and Q is true. If P is true, but Q is false, I'm going to call this statement false. Because remember, it is true only if both of them are true. Q was not true, so it makes it automatically false. Here, P is false, but Q is true, so I'm going to call this false. As soon as I see one of them being false, then P and Q is false. Now, both of them are being false, it remains false. Remember I said, as soon as I see at least one of them being false, it's false. So it is true only if P and Q are both true. Okay, let's take a look at this in wording. Evaluate the truth value of the following 2 statements. The capital of France's Paris, and there's a word here, and Antarctica is cold. So there's 2 statements. The capital of France is Paris. That could be true, that could be false. And then Antarctica is cold. That could be true, that could be false. Now, I'm going to look at each of them. The capital of France is Paris. That true? Yes. The Antarctica is cold. Is that true or false? True. Now, this whole thing, the capital of France is Paris and Antarctica is cold, I'm going to end up calling this true. Remember, it is true. When I'm using the word and, it is true only if all the statements are true. In this case, the 2 statements that I'm using are true. Therefore, this is true. Now let's take a look at B. The capital of France is Paris. So that's a statement. The capital of France is Paris. And the capital of America is Madrid. So there's 2 statements. I'm using the word and. The first one, the capital of France is Paris. That is true. The second statement, the capital of America is Madrid. That is false. So I have one of them is true, one of them is false. But because I'm using the word and, I'm going to say this conjunction is true only if both of them are true. As soon as I see one of them being false, which is the case, then this statement happens to be false. Now let's pick up the notch a little. Let's do a truth table for 3 propositions. I'm going to call them propositions P, Q, and R. Now, I know for P, I have 2 possible choices, could be true or false. Q, I have 2 possible choices, could be true or false. R, a third proposition, I have 2 possible choices because it could be false. Now, 2 times 2 times 2 will tell me how many rows I need to have in this table. 2 times 2 times 2 happens to be 8. So if you notice, I have 1, 2, 3, 4, 5, 6, 7, 8 rows. Okay, The half of 8 is 4, right? So my P, I'm going to go true 4 times because the half of it is true, and the second half it's false. Now looking at the truths, it's 4, I have 4 truths, right? The half of 4 is 2. So Q is going to be 2 truths and then 2 false. 2 truths and then 2 false. And then I'm looking at my truths. There's 2 of them. The half of 2 is 1. So with art, I'm going to be switching every one. True, false, true, false, true, false, true, false. Now here, P and Q and R. Remember, because I'm using the word and, it is true when all the statements are true. Otherwise, it is false. So it is true because I'm using the word and, it is true only when all the statements are true. So in the first case, I see all the statements being true, therefore this must be true. On my second case, I see one statement not being true. Therefore, this is false. Remember, when I'm using the word and, all the statements must be true in order for this statement to be considered true. Now, the second one, I see at least one false, therefore this must be false. Here, the third statement, I see more than one statement not being true, therefore this must be false. And then just to complete these, I'm just going to call this false, 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 false. Whenever you see in each row at least one false, and I'm using the conjunction and, if I see at least one false, and I say at least, it could be 1, it could be 2, or it could be all 3. When you see at least one false, it makes this false. So this is the truth table for P and Q and R. Okay, so the word and was not that difficult. How about the word or? Now the word or can be interpreted, can be seen as 2 cases. One of them we call it inclusive and the other one we call it exclusive. Now inclusive, which is the one we usually use, inclusive means either or both. So as long as one of them is true, it's fine. It could be one, if I'm comparing only 2 statements, one of them being true or both of them being true. That's what inclusive means. Now if I had 3 statements, one of them could be true, 2 of them could be true, or all 3 could be true. That's what inclusive means. Exclusive means only one. So if I'm comparing 2 statements, one or the other, but not both. So inclusive, at least one of them is true, or all of them. Exclusive means only one. Now, let's take a look at this statement here. Kevin's insurance policy states that his house is insured for earthquakes, fire, or robbery. So it's protecting it earthquakes, fire, or robbery. Imagine there's a major earthquake. So boom, earthquake happened. The first thing happened. Boom. Um, Imagine a major earthquake levels much of his house. The rest of it burns in a fire. Oh man, so we also had a fire. And his remaining valuables are looted in the aftermath. So robbery happened. All 3 things happened. Poor Kevin. Would Kevin prefer that the ORD in this policy, that the ORD in his insurance be inclusive or exclusive? Remember, inclusive means it could include either of these policies or all of them. Now, exclusive means just one. Pretty sure here Kevin would prefer inclusive, right? Pretty sure he would want his insurance to be earthquakes, fires, and robbery as well. Now, the logic of OR, given 2 propositions, P and Q, the statement P or Q is called what we call disjunction. So now we're going to be focused on the word OR. In logic, we always assume that OR is inclusive, okay, unless told otherwise. So now the disjunction is true if either or both of the propositions is true, which means that it is false only if both propositions are false. So when we're using the word OR, As long as we see a true statement, the whole thing becomes true. So let's do a truth tables for this junction, a P or Q. So if I ask you, give me the truth table for P or Q, you're going to say, well, P has two choices, Q has two choices, 2 times 2 is 4. So I'm going to need 4 rows. So P is going to be true the first half, and it's going to be false the second half. And then P is going to be every other one. Now, P or Q, as long as I see a true, one or two truths, this statement is true. So in this case, both of them were true. So P or Q is true. Now, if P is true, but Q is false, as long as I see a true, this happens to be true. If P is false, but Q is true, P or Q happens to be true. As long as I see a true, P or Q happens to be true. Now here, they're both false. So P or Q happens to be false. So P or Q is false only if both or all propositions are false. Consider the statement, airplanes can fly or cows can read. Is this true? I'm using the word or. And I see the first statement, airplanes can fly. And I see another statement, cows can read. I know airplanes can fly, right? That is true. Cows can read. I've never seen a cow read, so they cannot read. No. Now, is this statement true? Airplanes can fly or cows can read? Because I'm using the word or, I'm going to end up saying, yes, this is true. For the phrase or the disjunction or, as long as I see a true, this statement happens to be true. It is false only when all the statements are false. Now, there is what we call the if and then statement, and we're going to call that conditional. Now, I added some dots in there. If something, then something else. Let's see. Let me write something. Now, we call this conditional because we say the if part has to happen in order for the conclusion to happen. As an example, let's see. If you study, then you will pass my class. The if part, if you study, is what we're going to call the hypothesis, is the condition. So the if part, and I'm not saying the first part because I can switch things around. I can say, you will pass my class if you study. So I can rearrange this. So I'm just going to say the if part. The if part is what we call the hypothesis. The then part is what we call the conclusion. Conclusion is what we want to happen, right? My if part, my hypothesis, is my condition. So we're going to call this, if you study, then you will pass my class. That's what we call the if and then statement, which we call, at the end we call conditional. Now, there's a way we're going to abbreviate this. To be honest, we're going to abbreviate this. We're going to say my hypothesis, I'm going to call it P. My condition, let me call it Q. And in mathematics, we like symbols. We go P implies, we will use this little arrow, P implies Q. So if P, then Q. If you study, then you will pass my class. This condition is a statement. This conditional statement can have a true value, can have a false value, but it is a proposition. Let's actually work on the truth table for a conditional if P, then Q. Now, my p-value could have, I'm going to say half of it could be true, half of it could be false, and then my q value could be true or false, true or false. Now we're going to work on our conditional statement, if P then Q. The conditional, if P then Q, is true in all the cases except the case in which P is true and Q is false. Remember how I said the example, if you study, then you pass my class. I'm going to say I lied if you do study and do not pass the class. Right? You completed my condition. You did study, but you did not pass the class. So I guess I was lying when I say if you study, then you will pass my class. Now, what if you don't study? If you don't study and you don't pass a class, I wasn't lying, right? You didn't study. I asked you, or I told you the condition for you to pass is that you're gonna study. And if you did not study, then you did not pass a class. I wasn't lying. Now, what if you don't study, but you still pass the class? Was I lying? My condition was if you study, you will pass the class. I never said what will happen if you don't study. I never said that if you don't study, you will fail. So if you don't study, but you still pass the class, interesting. It is still true. The only time when it is going to be false is when the hypothesis is true and the conclusion is false. In this case, I'm looking at this case, the second case. When P is true, you did study, but the conclusion is false. That's the only time where my statement was a lie. Any other time, it is true. Right? If you study and you pass the class, I did not lie. If you don't study, but you still pass the class, I did not lie. If you don't study and you don't pass a class, I did not lie. The only time when I lied was where you did study, but you did not pass the class. So the conditional statements are false only when the hypothesis is true, but the conclusion is false. It's the only time. Now let's evaluate the truth value of this statement. If 2 plus 2 equals 5, then 3 plus 3 equals 4. Wait a minute. 2 plus 2 is not 5, and 3 plus 3 is not 4. I'm not asking you if 2 plus 2 is 5 or 3 plus 3 is 4. I'm asking, give me the truth of the statement. Like, is this a true statement or is it a false statement? If you notice, we know 2 plus 2 equals 5. That's a false statement. 3 plus 3 is 4. That's also a false statement. So in this case, I'm looking at this case. My hypothesis is false. My conclusion is false. So my statement must be true. Because the only time when a conditional statement is false is here. If 2 plus 2 was 5, but 3 plus 3 is not 4, then that will be a lie. That's the only time when it is false. So this statement, if 2 plus 2 equals 5, then 3 plus 3 equals 4, happens to be a true statement because the hypothesis and conclusion were both false. The only time when the conditional statement is false when the hypothesis is true, but the conclusion is false. Other ways of saying if and then are P is sufficient for Q, P will lead to Q, P implies Q, Q is necessary for P, Q if P, or Q whenever P. Now, if you guys are thinking, oh my God, this is kind of confusing, that's when I said wording. Sorry for my English teachers, wording is actually what makes it confusing. In mathematics, we like to use symbols, so most of the time, we're going to do this. P, then Q. And then you can read it however you want. P is sufficient for Q, P will lead to Q. P implies Q. However you want to, whichever phrase you want to use for English is what we mean with this symbol. Notice how mathematics is a little more simple. Like I said, sorry, my English teachers, but yeah. Now let's rephrase each of the following statements in the form if P then Q. I'm gonna write each of this as a conditional statement. And then we're gonna discuss whether the statement is true or false. My first case is a rise in sea level will devastate Florida. So it is not as an if and then statement. So it makes sense that I have rephrased it. So notice here it says a rise in sea level will devastate Florida. So what will happen? The sea has to the sea level has to go up. So I'm gonna rewrite this as if sea level rises, if sea level rises, once I finish my hypothesis, my if statement, I put a little comma, then Florida will be devastated. Now, this is true or false. Let's say, remember, the only time where this thing is going to be false if the true statement is true. I mean, the hypothesis happens to be true, and then the second statement happens to be false. So let's do say the sea level does actually rise. Well, Florida will go under sea level, right? So it will be devastated. So yeah, it will happen to be true. So then this happens to be a true statement. Okay. So B, let's take a look at example B. A red tag on an item is sufficient to mean it is on sale. So the way I'm going to rewrite this is if an item is marked with a red tag, comma, because I finished my hypothesis, then it is on sale. Yeah, this also happens to be true. Yeah, if I go to the store and I see an item with a red tag, yeah, it is on sale. Now, eating vegetables is necessary for good health. So I'm gonna write this if a person is in good health, then the person eats vegetables. I'm really looking for me to make this a false statement. I'm really looking for my hypothesis to be true and my conclusion to be false. And let me see, can I come up with such case? So I want a person to be in good health, but the person not eat vegetables. Can that happen? Can that happen? What if a person is in good health, person does not eats vegetables, but that person goes to the gym every single day? That could happen, right? Therefore, this statement is false. Now, conditional statements, we can play with those. There's variations on those. We said the conditional statement is in the form if P then Q. For example, let me change P and Q for actual statements. For example, if you are sleeping, then you are breathing. That's a conditional statement. If P, then Q. But there's this thing that we call converse. Converse, we're going to switch the hypothesis and the conclusion. So instead of if P, then Q, we're going to call it if Q, then P. As an example, from the first example, if you're breathing, then you're sleeping. Notice how my hypothesis and conclusion got swapped. That's what we call converse. Now we also do what we call inverse. Starting from the conditional, all I'm going to do is I'm going to keep the hypothesis and conclusion the same. I'm just going to negate each of them. So I'm going to go if not P, then not Q. My original conditional statement was if you're sleeping, then you're breathing. My inverse will be if you are not sleeping, then you are not breathing. So I just negated the hypothesis and conclusion. Now the funny one is the contrapositive. The conditional statement to begin with was if P then Q. For the contrapositive, the hypothesis and conclusion switch and you negate both. So if P then Q was the original conditional statement, contrapositive is if not Q, then not P. So an example, the original conditional statement was if you're sleeping, then you're breathing. My contrapositive will be if you are not breathing, then you are not sleeping. So I gotta know what each of these does. Okay, let's play a little. We're gonna play our truth tables here. So my P and my Q, those are my two statements. P and Q. P could have two values, Q could have two values. 2 times 2 is 4. So it makes sense to have 4 rows. For P, I'm gonna do every two trues and 2 false. For Q, I'm gonna do true, false, true, false. Okay, so not P. I'm gonna check out a few things here. Not P. I'm looking at my row P. Not P is the opposite of P. So when P was true, not P is false. When P was true, not P is false. When P was false, not P is true. When P was false, not P is true. Remember, not P is the opposite of P. So that means that not Q is the opposite of Q. So here will be false, true, false, true. I did the opposite of Q. Now, if P then Q, so I'm focused on if P is my hypothesis and Q is my conclusion. It's a conditional statement. Remember, conditional statement is false only when the hypothesis is true. So this is my hypothesis, and then my conclusion is false. So here, if the hypothesis is true, the conclusion is true, this is true. If the hypothesis is true, the conclusion is false, that's the only case when this thing is false. If the hypothesis is false, but the conclusion is true, this is true, and this is true. Like I said, it is false only when the hypothesis is true, but the conclusion is false. Now let me take a look at the converse. Remember the converse was if Q then P. So that means this thing, the Q, it's my hypothesis, and P in this case is my conclusion. A conditional statement, remember, it is false only when the hypothesis is true and the conclusion is false. So that happens to be this case. Only when the hypothesis is true and the conclusion is false. That's when this conditional statement is false. Otherwise, it is true. If not P, then not Q. That's the inverse. So now I'm looking at not P is my hypothesis. Not Q is my conclusion. And remember, in this conditional statement, it is going to be false only when my hypothesis is true, but the conclusion is false. So that happens to be here. So again, when my hypothesis is true and my conclusion is false, that's when this statement is false. Otherwise, it is true. Okay, the last one, the contrapositive. If not Q, so not Q will be, in this case, this will be my hypothesis. Then not P. So not P will be my conclusion. Remember, the conditional statement is false only when the hypothesis is true and the conclusion is false. So that happens here. The hypothesis is true and the conclusion is false. Otherwise, this is true. So that's how we complete the truth table for the variations, for the conditional, converse, inverse, and contrapositive. Now, some rows might be identical. So I have these right here. I typed it in so it's easier to read. Now, two statements are logically equivalent if they share the same truth values. If one is true, so is the other. If one is false, then so is the other. An example. Take a look at our original conditional statement, and let's take a look at our contrapositive. Do you see the truth values being identical? Therefore, these two are logically equivalent because they have the same truth table. What about this other two? Yeah, they're not logical equivalent to the contrapositive and the condition, but they are logically equivalent among those two. So the converse and the inverse are logically equivalent. So here I wrote this. The conditional and contrapositive are logically equivalent. The converse and the inverse are also logically equivalent. So remember, we call those logically equivalent only when they have the same truth values. Now consider the statement, if a creature is a whale, then it is a mammal. We're going to write the converse. Then I'm going to focus on the inverse and then on the contrapositive, and we're going to evaluate the truth of each statement, which statements are logically equivalent. Now, right now, again, I'm just going to do the converse. Remember, I'm going to do here, a creature is a whale. That's what I call my hypothesis. Then it is a mammal is what I call my conclusion. I remember converse, they switch. The hypothesis and conclusion switch. So I'm going to write, if a creature is a mammal, then it is a whale. But then I'm going to evaluate the truth of the statement. It's a conditional statement, so I'm trying to come out with the false. I remember this is my P now. This is my hypothesis. My then part is my conclusion. So let me label this. This is my hypothesis. This is my conclusion. This statement is true only if I can come out with an example. If I can think of an example where the hypothesis is true, but the conclusion is false. So I'm asking, can you think of a creature that is a mammal? Because I want the hypothesis to be true. Can you think of a creature that is a mammal, but not a whale? I'm thinking of a dog. A dog is a creature that is a mammal, but not a whale. So I was able to come out with an example. So therefore, this statement is false. Now let's work on the inverse. I'm going to have the same conditional statement. If a creature is a whale, then it's a mammal, but I'm going to work on my inverse. I remember my inverse, I called it not P, not Q. Basically, I'm going to just negate. I'm going to negate the original hypothesis. I'm going to negate the original conclusion. So initially, I see my if and my then. I identify those. My if is my hypothesis part. I'm going to negate that. So I'm just going to say if a creature is not a whale, then it is not a mammal. This is my new hypothesis. This is my new conclusion. I'm trying to make this a false statement. I'm trying to come out with an example where the hypothesis is true and the conclusion is false. So can you think of a creature that is not a whale, but it is a mammal? Again, I said it is a mammal because I'm negating the conclusion. Can you come out with a true hypothesis and a false conclusion? Can you think of a creature that is not a whale, but it is a mammal? I'm thinking of a dog again. Therefore, I was able to think of an example that makes this false. Therefore, this is false. Now let's work on the contrapositive. Still think of the original conditional. We're going to write the contrapositive. I remember for contrapositive, I negate everything and then the hypothesis conclusion switch. So I'm going to write this. Remember, in original, I have my if and then, but again, my statements are going to be negated and they're going to be swapped. So I'm going to write this as if a creature is not a mammal, then it is not a whale. That's my contrapositive. My new hypothesis is this one. A creature is not a mammal. And my new conclusion is this. It is not a whale. Now, for the truth or false statement, I'm trying to think of this being false. Can you think of a statement where the hypothesis is true and the conclusion is false? So can you think of a creature that is not a mammal, but it is a whale? Remember, I'm going to keep the hypothesis true and I'm going to negate the conclusion. Can you think of a creature that is not a mammal, but it is a whale? No, we cannot. Therefore, we cannot think of an example that makes this false. Therefore, this must be true. Have fun with your homework.